Hi everybody, this is Mr. Longo, and we are going to talk about graphing quadratics and more importantly how to use our TI graphing calculator to find a whole bunch of important information and to guide us with graphing. So before we get to graphing, I want to talk about the three different forms of a graphing quadratic. We have a standard form, which is y equals ax squared plus bx plus c. Now, standard form equation has one special power, and that is C tells you what your y-intercept is. Because remember, a y-intercept is always when x is equal to 0. So if we substituted 0 into both of those x's, the only thing we're going to be left with is C. We have vertex form. Now, vertex form is created by completing the square, and we are going to come up with a vertex form, which is y is equal to a times the quantity of x minus h squared plus k, where your vertex is h comma k. So it's opposite of what's inside of the parentheses comma the outside of the parentheses, h comma k. And your axis of symmetry is always going to be x equals whatever your x coordinate of your vertex is, because it's what splits the quadratic graph in half. And the third form is intercept form, which is y is equal to a times x minus p times x minus q, where p and q are your x-intercepts. Now, the a actually tells you quite a few different things. If a is positive, your quadratic is going to open up. If a is negative, it's going to open down. If a is 1, it's going to be a normal-shaped quadratic. But if a is bigger than 1, then it's going to be vertically stretched. So it's going to look a lot skinnier, but it's basically just rising a lot quicker. And if a is less than 1, not negative, the negative tells you it opens down, but any number less than 1, it's going to make your graph vertically compressed. Okay, so that's what the a does. Now, I have 3 examples here for you. And I'm going to show you how to use your graphing calculator to do a lot of it. But I am going to tell you right now I'm going to jump around a lot because I want to stick to a specific topic first. And that is just being able to look at the equations and decide what the orientation and what the shape is going to be. We do not need a graphing calculator to do that. So, the first one, it's positive. We have a positive x squared. So that's going to open up. In our second example, it's negative. So it's going to open down. So then obviously the last one's positive again, so the orientation is going to open up. Now let's talk about shape. Shape is determined by your a value. If your a value is 1, it is a normal shape. If the number in front, ignore the negative. If your a value is bigger than 1, then we have a vertical stretch. But if our a value is less than 1, we have a vertical compress. So we do not need our graphing calculator to do any of that, okay? Next, I want to talk about what we can determine from the graph without needing a calculator. So if we were to look at the first one is in standard form. And remember, the standard form equation will tell you that the c value is your y-intercept. So we do not need a graphing calculator to tell us that our y-intercept is 0, negative 1. Because that's what it's always going to be when we are in standard form. For the second one, we are in vertex form. Remember, the vertex is h, k. So, opposite of what's inside, outside, our vertex is negative 3, a negative 2. But remember, our axis of symmetry is x equals the x coordinate of our vertex. Okay, so there we have something else, another superpower. And finally, in the last example, this is in intercept form. We will not need our graphing calculator to tell us opposite of P and opposite of Q. We have a negative 4, 0 and a negative 1, 0 for our x-intercepts. So again, I wanted to take a little bit of time to just show you what you can do without a graphing calculator when you have each form. All right, so now we're going to go do the rest of the information. So we're going to start with this first one, x squared minus 2x minus 1. So you take your calculator, you click y equals, and you type the equation into y1. So we have x squared minus 2x minus 1. And in y2, I'm going to tell you to type 0. Now, there's a reason why I'm going to tell you that. It makes finding your x-intercepts a lot easier than the other way you can use your calculator to do so. And then you click graph. And we have a graph that looks like that. And you're like, hooray, that looks great. However, wouldn't it be nice if you had some better points? Well, we can press second graph, and we can do just that. We can plot some nice points. We know we have a y-intercept at 0, negative 1. But we can use our graphing calculator to find more good points. We have a negative 1, 2. We have a negative 2, 7. So we have lots of other points we can find. We have a 1, negative 2. And then we're going to bounce back up to 2, negative 1. There's a red flag right there. Now we're going to consistent points. When that happens, we know that that bottommost point is going to be our vertex. Now I'm still going to show you how to use your graphing calculator to do that. So to find a vertex, we have to notice that it's at the bottom of that curve, which makes it a minimum value. So if we take our calculator and press second trace, it'll take us to the graph and calculate menu, and you'll see number 3 is a minimum. And then our calculator is going to give us step-by-step instructions. It's going to say left bound. That means you take your little blinky or your spider on the graph and you take it to the left of what your minimum is. So we can see the minimums right here. So just keep it to the left and click enter. Then it's going to say right bound. So now you just take your little spider and you press right to get to the right side of that minimum value. And you click enter. And now you just go down to your minimum value, click enter one more time, and we can see that we get 0.99999 and negative 2. Well, let's use our head here and say that that will just round to 1. So our vertex can be found by finding either a minimum or a maximum. In this case, it's 1, negative 2, which means our axis of symmetry is x equals 1. And now, how do we find our x-intercepts? Our x-intercepts can be found by pressing second trace, number 5, intersect. Now, there is a 0 feature, but I find it easier to just find the x-intercepts by typing y2 equals 0. See, if you didn't have y2 is equal to 0, you wouldn't be able to find the intersection of anything. And then once you get there, you just click enter 3 times. 1, 2, 3. And one of our x-intercepts would be at the coordinate 2.414, 0. Now, since there are 2 of them, you would just have to press second trace, number 5 again, but this time you would move your little spider or your blinky to that intersection. And if you were to do that, you would get another coordinate, which would be negative 0.414, 0. Okay, now you can use your calculator to do that if you'd like, but I'm trying to save on some time here, so that's it for that. So now we know how to use our calculator to find a vertex and our x-intercepts. Now the second example here, we have another graph, and we would go to y equals again, and we would just change y1. We want to leave the 0 in y2, and we would have a negative 2, parentheses, x plus 3, quantity squared, and then minus 2. And remember, we were already able to state what the vertex and the axis of symmetry are. But of course, if you were unsure, you can always find the maximum or the minimum just to double check to make sure you're right. So we're going to click graph here, and we're going to see that this one is upside down. So we have no x-intercepts if you were to look at that guy. So our x-intercepts are going to be none. I mean, you can't find an x-intercept if it never touches the x-axis. So how do we find the y-intercept? Well, obviously this y-intercept is a little bit off the graph. Special note, if ever you want to see something that's not showing up, think of where it's going. The y-intercept is somewhere below -10. So you can just go change your y minimum to, I don't know, maybe try -25. Click graph, and you can see that it'll cross. But we don't need any special features. All you need to do is remember, it's when x is equal to 0. So if you press second table, if we look at 0, we're at -20. So we're going to have a y-intercept at 0, -20. And of course, to go graph it, yes, we can just go to our -3, -2. We could go to the table and plot some good points, and we'll end up, you know, going down like this. And that's good. And our x, just so you guys know, the axis of symmetry is always a vertical dashed line that splits through the vertex of your graph. It's never a solid line. Okay? So you now know how to use your graphing calculator to find a vertex, which means you also know the axis of symmetry. You know how to use your graphing calculator to find x-intercepts by finding the intersection. And you also know how to use your graphing calculator to find the y-intercept. So we already know the x-intercepts of this last one because it's in intercept form. But I would like you to pause the video and just try to find the vertex, axis of symmetry, and y-intercept on your own by pressing the buttons, and we'll see if you get them right. As soon as you're ready, click play, and we'll see if you got them. Give it a shot. And here you go. If you found a vertex at -2.5, -0.75, and an axis of symmetry at x equals -2.5, you are correct. You just had to find a minimum with your left-bound, right-bound guess. The y-intercept, if you press the second graph, your table would have told you that it's 0, 1.333. However, we know that's also 4/3. Either one is correct. All right, so that's how you use your graphing calculator to assist you with graphing quadratics. This is Longo, and I'm out. See you, bye.